So I'm delighted to welcome Thyaga. He's the Director of the Division of Innovation and Technology Ecosystems in the TIP Directorate at the NSF. With an annual budget of over 350 million, he oversees NSF investments in convergent and translational research in emerging technologies and in building inclusive innovation ecosystems around the country. He is also the co-chair of the NSF-wide Quantum Leap Steering Committee that coordinates NSF investments in interdisciplinary research in quantum computing, communications, and sensing. He serves on the NSF-wide Semiconductor Steering Committee that coordinates NSF investments in semiconductors, microelectronics, and packaging. Beyond that, Thyaga holds over 30 patents on software-defined networks and wireless technologies. He's an IEEE fellow and holds a PhD degree in electrical engineering from the University of Illinois at Urbana-Champaign. So welcome, Thyaga.
Thank you.
Thank you.
All right, perfect. Okay, I think I want to go back to NSF's history in pursuing open source research, right? So this is something that we take a lot of pride in. Many of you may know the internet as something that DARPA originated, but by the time DARPA was done with the internet, it was actually still a very exclusive DoD-only network, right? And NSF had the vision to take that and make it more widely available and literally open it up. Right? Openness was something that was a hallmark of NSFNet, the first network that took in the internet, the so-called rudimentary internet of stretches, and brought it into the open for use by academics. And from then on, it just ballooned and mushroomed. Right? And NSF played a critical role in connecting different people, enabling the agreements that had to be signed to make that a robust infrastructure that was still available and open. And similarly, we pursued that notion when we expanded the internet into Internet 2 by deploying the high-speed backbones that we all have come to take for granted, right? And I mentioned a little bit about software-defined networks. The interesting piece about the entire Stanford project was it was funded out of an NSF Expeditions grant, which is a large center-scale award, $10 million award made to Stanford back in 2007 on a totally different concept, programmable mobile networks, which sounds very familiar today. But the SDN notion came out of that particular project, right? And of course, enabling companies like Google. Now, Google obviously is like a huge open source champion, but what I do want to say is that Google came out of this project called Digital Fountains, which aimed to open up the vast trove of knowledge to mankind. How do we enable the digitization of libraries and make them more widely available to people? And that essentially led to that discovery, the ranking algorithm, page rank algorithm, which led to the foundation of Google, right? So a lot of these things, again, the whole notion of how we have built out the internet. So if you are a a telecom industry veteran, you can probably see the difference in the pre-1995 era, where it was telecom close. It's dropping off. Okay, it's still working. Okay, so it used to be proprietary systems, and then of course, suddenly after 1995, everything was open, right? The whole dot-com boom was unleashed by the availability of that openness, right? The open architecture, open protocols that allowed you to innovate faster, innovate quickly, right? And that is the culture that we have come to take for granted. That is happening. Okay, I have no idea. I hope it continues to work. We'll keep going. So that's what we want to really keep going. Keep pushing forward for wireless. Now, when we talk about wireless, it becomes a little bit more complex, right? In the wired world, it was somewhat, I would say, there's architecture, there's the hardware, and there's the software. In the wireless piece, we now have additional pieces here that come in the middle. Starting with the notion of spectrum. Right, we need spectrum, which is highly regulated and a very complex beast by itself. And what does openness mean there? And we have come on to rely heavily on additional pieces here, right? Now, wireless is not just plain wireless; it's all integrated with other parts like AI, computing. You need data sets, you need test beds, and so forth. So there's a lot of different pieces that have started commingling in order to provide a robust system. And the notion of openness, in my mind, has to pervade all of it. And when Paul was flashing the agenda, aware that you are already thinking along those different lines. You cannot just build a system just for, oh, let's just focus on just the software, but that it actually has pieces. So I want to talk a little bit about some of our efforts. I will say that within NSF, while we take a lot of pride in this, we also federal agencies that are working in parallel with us. And I'll call out particularly our partners in the Department of Defense and the National Institute of Standards and Technology, very closely with us on many of these efforts. So I think a lot of credit goes to them too. So I'm going to just sum up our efforts, but be aware that there are other parallel efforts happening in this place. So spectrum, we really think that we have to change the notion of how spectrum is allocated and designed. And why does it tie to this notion of openness? So finally, spectrum as allocations made closed rooms based on like a few, I would say, I wouldn't even call them data-driven policies. It's more like must come first served, somebody who has the loudest voice. Those kinds of policies seem to kind of dominate how spectrum allocations have happened traditionally in the past. What we really need is more of informed, open process for making these allocations. And I would even say more dynamic, right? And I think because it's not a static process, it's not a static use model as well. Spectrum use varies by location, by time, and by application, and it's important for us to kind of be aware of it. So some of the things that we are trying to fund in this space, like National Radio Dynamic Zone, is like this massive testbed effort that we are trying to talk where how to experiment with spectrum in a safe way where we can flexibly utilize test out all these different policies. We have a whole bunch of other efforts around this, but in particular, I want to call out the Spectrum Innovation Center. There's the Spectrum X. This is a national effort. We really hope to focus on the science of spectrum management by producing research studies and data on how we can make this entire process of allocating and managing spectrum flexible, automated, and cloud-based, right? So a lot of work happening in there. Are there any members from here today? Anyone from Spectrum X team here? Okay, all right. So I hope you all kind of plug in. So they have regular radio, they call it radio chats. So there's a pretty good, interesting topics that they come up with. And I think you're going to hear from tomorrow about the testbed. And again, this is the Power Platform for Advanced Wireless Research that started in 2017 or so. And we have 4 testbeds and 1 internal inside emulator in the Northeastern. So, and I see Hongwei sitting here somewhere. Yeah, Hongwei is here from the ARA testbed. So thank you, Hongwei, for your work there. So, and again, when we started this effort, right? So we most members of the community wanted their own test beds. Like, we wanted to set up our own test bed within our own labs, but as a certain site test bed in a certain place in a particular, you cannot really grow it, make it too big, and the money is not enough to enable everyone to have their own large scale. And we had this vision, create this very city scale test beds that will allow anyone anywhere in the country to log in remotely and operate a real life network testbed, right? A 5G testbed. And again, at that time, 5G was not a thing, right? We call it next generation because we want not just to be for 5G. We expected this to continue operating beyond 5G and support the next generation research as well. And again, not just the cellular, but also other types of technologies too. How many of you have used a power testbed? All right, small number. And I would encourage you to think about you logging into any of these. And Murray is going to talk a lot more tomorrow. And I hope that you actually see that and take them out for a test drive, because many of them are actively participating in own testing and development. And if you are trying to get started, there's no better place than to get started because they kind of walk you through the entire process and give you that wide range of scenarios that many of you may not have access to within your own labs. Okay, the key is because these platforms are getting certified as OTICs already, right? So you have 3 already as part of the OTIC portfolio, and we have 2 that are on their way. And each of them have a unique application scenario, right? So the powder test bed, for example, has this large testing. The Cosmos project has a much more millimeter wave and urban canyon kind of testbed focus, and ARA testbed has wireless rural connectivity focus, right? So you have different use case scenarios that you can test. And I would say that we really think that this particular testbed is probably the most powerful in right now anywhere in the world. And again, somebody can prove me wrong, but until you prove me wrong, I'm going to make this claim. From what I've seen and what I've heard, these are the most powerful test beds that you have today in the world that can provide this kind of support. So I encourage you all to take good advantage of it. And again, why, going back to openness, right? So why is this important? We believe that if you can't test and validate your ideas at scale, nobody's going to bother. You can publish your papers from your small lab test beds, from your small 5 nodes, 4 node results. That's fine. But how does it matter? How does industry pay attention? Industry is not going to pay attention to it unless you can say this actually works at a larger scale. And I'll tell you, as much as industry likes to push the bandwagon of 5G and next 6G, research labs are also cash-strapped. They really don't have the ability to say, oh yeah, somebody here has an amazing idea. Let me go test this at a larger scale. Want to see it happen somewhere else, they can make the business case for their units to take this thing, right? And this is the internal, I don't know how many researchers here would disagree with me from the industry side, but I have seen this firsthand when I was in the labs. You had this amount of money being thrown, but then you ask people, what is the R&D budget that you have to test something new? They say, very little. I don't have room space for that, right? Much of it goes for like the actual product units to do work, right? So if you want to demonstrate the validity of your ideas, then you have to go here, right? And the beauty of this platforms, and the way we have architected these is they're all open source, right? Open source based. All the major open source projects that you think of in this wireless space, both on the wired and the wireless side, they're fully supported in these profiles, right? So you can load them up as profiles and test them up and get them going. One of the beauties of open source, essentially, so when you develop or augment the code and you make others, make it open for others to use, they are going to benefit from it. So the entire test base is to allow you to develop, create or augment a particular profile and let it sit there for others to test and verify. So it enhances reproducibility and helps others build on it and hopefully, see. So that's basically the idea. So that's the test. Another component I would say is, again, this whole notion of bringing intelligence into AI. And I believe there's a talk tomorrow that specifically goes into AI use cases. And I think I'm glad to see that SRS is already out there enabling those use cases. Again, this is one example project from Mississippi State. And, I think is Wook here? No, I don't. Okay. So it's, again, how do you integrate Open RAN and bring this open AI, so to speak, right? By bringing that into a flexible core that can learn real time from what is happening on the network and provide better management of the entire radio and the wireless subsystems, right? So that's an interesting project. This is just one example, and there are many, many possible examples. Again, it won't be possible if you're not publishing this Open RAN stack, this whole open is in between, to allow people to look at how messages are being passed between the subsystems and how do you optimize them. So that's something that we want to think about. The major piece when it comes to what I think is the necessary component of innovation in wireless is the notion of data. This is something that has long cramped any kind of innovation for us. And many of our earliest efforts that have really tried to seed this have fallen flat mainly because we all dump our test beds and without any kind of appropriate ontology or semantic consistency, and just hope that somebody figures it out, right? So we have tried to bring some discipline into this process. One of our latest efforts, right? So RF Data Factory hosted at Northeastern, and we really hope that this one, among many other parallel efforts happening, has the ability to bring some level of consistency in terms of that semantic knowledge that we can develop around RF data, right? And again, this also is complementary with the millimeter wave channel model alliance, for example, that the NIST folks have been running for a very long time. That has been a phenomenal streamlining and bringing some, what do you call as consistency across how different vendors and operators speak about millimeter wave data, channel data. So to do something similar when it comes to RF data here, right? And again, there's a whole range of use cases here. You can look at it like across UAVs, vehicular communications, Open RAN, and so forth, right? So if you have not used this, feel free to check this out, right? And not just check it out, contribute, right? If you contribute, we all become more successful at it. How many of you have seen this before? RF Data Factory? Okay, few hands. Okay, so SJ, we need to pass this on. So no matter how much we try to advertise, we have to do more, right? So I'm calling out SJ specifically there because he's my program officer in the working on emerging tech, specifically wireless, and he's going to be around today, and you should talk with him for on additional details on some of these projects. Okay. Perfect. We believe that open source is not just software. We also believe that openness in hardware is also an important piece. Now, of course, most people have thought of SDRs as software-defined radios to some extent as the enabler, and say that our major challenge with the previous generation SDRs was that they came after the fact. So we got the first custom radios in the sub-6 bands, the FR1, so to speak, and then SDR more flexible experimentation, though they ended up being largely confined to the experimental domain as a result, because there were custom radios that were much better performing that came well before the SDRs came on the market. So even to this day, SDRs that you normally think of, the USRPs and others, are the realm of experimenters. How many of you in industry use SDRs on a day-to-day basis? Okay, do you use it for production? Exactly, right? So like that, see that is basically a challenge, right? And why not? So we use OpenFlow, we use SDN code, like software code, on a production network. Why are we not able to do the same thing on hardware, right? Because we think of SDRs as this not so good, but good implementation hardware. That's an assumption that we are making, right? So what if we can create the next generation of open hardware that can actually provide that high performance and still be open enough to allow experimentation, but also be good enough for production systems, right? So that's something that we are hoping to do, enable, right? We had a workshop last month at Chicago. And what we try to do here is, we're not going to go back and change the sub-6 world or what I think of the millimeter wave bands, which is a little bit challenging in terms of providing hardware as it is, but focus on these newer bands that are coming up, that the FR2, so to speak, sorry, FR3, which is the 7 to 24 gigahertz bands, right? There is literally no commercial grade hardware that is being talked about now, but there's a lot of rulemaking activity happening on the FCC side. So our hope is that if we can get the community to start thinking about what does it take to design something from scratch that has both of this power, flexibility, and performance features in one go, then if we can create that nice, beautiful ecosystem of software and hardware that allow us to develop these units, that will be a fabulous effort. So this is something that we are hoping to do. If you're interested in this, please talk to us today. And of course, I'm going to be here for a while, so I'm happy to hear your thoughts as well. But again, we think that this is what I think is a greenfield territory, right? An opportunity for us to shape the landscape, both on the software side and the hardware side. And again, since you're all srsRAN adopters, don't think of yourself as doing the traditional conventional wireless sub-6 stuff. Like, to think of, how whatever work you're doing, will be future-proofing by future-proofing yourself by working in this. And I want to call out a specific program that our division, our directorate has funded. This is called a Pathways to Enable Open Source Ecosystems. So this program has been in existence for about 1.5 years now. All was out recently. So one of the experiments that we have enabled is this notion of this creating the broadband prairie project that I think Hongwei is involved in that one, right? So that's great. So this is about creating broadband rural research experiments for open source software, data, hardware designs, right? To integrate them for rural focused broadband solutions. Again, creating the ecosystem of hardware solutions. Now remember, it's not just about delivering broadband to the average consumer. So in the rural environment, you're talking about rural kind of connected components like tractors, right? Sensors and all of them. So you need a robust ecosystem that is kind of disconnected from the farming monopolies. You don't want John Deere and Caterpillar to essentially, they already own the farms. You know, everything else too, right? So you want to create competition into that space. And the purpose of creating this open source ecosystem is to allow that healthy community and software tool systems like tool chains to provide that kind of robust ecosystem there. So that's one. But this is just one example, right? This is a program that I really hope that the wireless community embraces. We actually got only one proposal last cycle, which, trust me, I was shocked. Given all the talk about open source here, literally nobody stepped up for this one. So if you care about this, and again, it doesn't have to be just ORAN, it doesn't have to be SRS, but there are other things that you are pursuing, feel free to check out Pathways to Enable Open Source Ecosystems project. It's called POSE, P-O-S-E. Okay. But anyway, I just want to pause a little bit, right? I don't want to go through this, right? But different topics in there. Many of these are research projects, but they all touch on a range of components where open source plays a role, right? And not only are they leveraging open source, they're all open source tools and so on. Now, obviously, none of those creation efforts will be successful if they build on others' efforts further beyond that. The challenge for us as a community is to say, how do we create these interconnections and how do we help the folks to go past each other in their narrow, oh, I'm going to develop this code, publish it and forget about it. So just because you publish it on GitHub doesn't make it open source, right? Yes, you have met the definition, you have made it available, but that doesn't get you anywhere else, right? So that's something to think about. How do we actually create that ecosystem that builds on each other? And that's a conversation that needs to happen among all of you, right? So Paul took a great leap forward by pushing out, developing resources, developing this code and putting it out there and backing it up with headcount, like people who can follow through on your request. Like, oh, I have to work on this. I have this change request, and taking in feedback from all the changes that you guys are suggesting and putting it. So that is what has helped create this room full of folks who are eager and interested in working on this further. All of the software development projects or even hardware projects that we want to make open source have that same challenge. If you don't get a passionate enough community behind it, you're not going to be able to successful at it. But if you may be thinking, I don't know if I can do it, right? Is it me? Why should I do it, right? And I'd say, I think I like what Louis said. Many of the folks in this room were walking sleep aid into his classes at 8 a.m. in the morning. So talk to these folks and figure out what made it click for them. Why did they make that switch? Doesn't mean you get to be a poor developer who has no money or resources. I think Paul is pretty happy with where he is right now. So there is an opportunity to make money as well, have a pretty good lifestyle. So it's a combination of both. So I want to think about it and talk to these folks. Now, I think it's fairly obvious to you, just to go a little bit into where we are with respect to 5G and Open RAN. You're all users of this, and you probably know, like you already get the cost advantage, you get the functional flexibility, and and you can get things faster to the field. So I don't want to kind of reiterate these particular pieces in there. What I do want to highlight notion of this, the very last bullet, the private 5G deployments. One of the big barriers to open source today is that no one wants to bite the bullet and say, I want to deploy this large scale. And this is where it's extremely instrumental for us to go back to history and derive a lesson from what happened with software-defined networking. Software-defined networking itself would not have been successful in a regular traditional internet model. No one would have appended like the Cisco routers and started to put in an open flow switch there. Why it was successful was this notion of data centers. Data centers was a completely new concept that came in and allowed someone to create a private enterprise, like, that's completely walled off. There's a gateway connecting you to the data center, and that offered a certain ground where open flow and as software-defined networking in general could prove its value, right? So we are in a similar situation with 5G right now. No operator will want to change their current 5G deployment, or even, let's say, even going into 6G, they may say or say the right things. They don't want to replace the mass commercial market deployment based on the open source product. Because it's a chicken and egg. I want to know if it's going to work well in the field before I deploy it larger, but how am I going to find those results without putting out in the field first? And this is where I think private deployments are going to be very, very helpful. And 5G conveniently is architected to support that, those kinds of 5G deployments, enterprise 5G deployments. Now, there is still a little bit of a chicken and egg because some of the big carriers are hesitating to do that. But luckily, we have folks like Rakuten and a few others who are actually going out and taking the risk and doing so. And I think this is important for us. And the results that you are developing, the work that you are doing is going to be important. If you are an industry person who can talk to some of your customers, and if you have the ability to influence the deployment of private enterprise networks, push for open source ecosystem deployments, push for things that are based on srsRAN or anything else that catches your fancy, and say, let's go out there and these are ready to go. And they're small enough that you can debug and fix performance issues on the fly. Contrary to what one believes, none of these major networks through their own sets of downtimes, you just don't see it as a customer. They do a pretty good job of hiding it. So if you have any level of influence with the industry or with your customers who are in private deployment, push for open source. So that's my request to you, right? Without that, we'll be here 10 years from now, still talking about why open source has not taken off, right? But if we can capitalize on this particular moment, I think 6G will by default be counting on open source to deliver. Right? We got this narrow window of about 4 years to make that case. It used to be 6 years. Now it is shrinking rapidly. So yeah, let's count on that, right? And again, this is why I keep thinking that can make the case for a robust set of deployments in the private market in 5G, then 6G will become fairly easy for us as an open source community to push for, mainly because we are going to be seeing a true heterogeneous connectivity in the 6G model, right? Satellite networks are already changing the dynamic of where and when you can connect anywhere in the country, right? Starlink will become a viable alternative, and especially now with the direct-to-phone option, it is literally changing the game in many parts of the world, and like many are scared in certain markets. But it's not easy to develop a closed system that incorporates all of these different components. There's no way an Alcatel or a Nokia, sorry, I keep saying Alcatel. Alcatel doesn't exist anymore. Nokia, to develop an integrated closed source system. Open source is going to be the best way to make it happen. And that requires us to start thinking about how those different components will exist. Now, the satellite community, satellite networking is not open source today. It's a heavily closed source system, right? But if we can demonstrate the value of engage of how open source can perform in the 5G deployments and show how you can create the APIs and hooks for other types of networks to interface with it. Again, expanding the notion of ORAN, like blow up the interfaces, create those definitions, we can see that true interoperable network across the board. Okay, and again, I also want to iterate this. It's not just about the current cellular bands. It's about additional bands. We are going to be opening up more and more spectrum. As I said, we are going to be looking at the 7 to 24 gigahertz and so forth. But you need to start looking at it and focus heavily on reliability and redundancy, right? So we are not going to get anywhere if somebody can make the argument that open source fails more often than a regular traditional industry code base, right? That's going to require resources. And of course, we have to dedicate ourselves to testing, better documentation of our code, better practices in terms of sharing results, sharing knowledge, not just what works, but also what doesn't work. Okay, if we cannot commit to that, then we are not going to be able to achieve the reliability that you expect in network deployment. And I'll say why people care about this, right? If your network doesn't work, even for a minute, you are very unhappy, right? I mean, how many of you are below 20 here? No one, right? So any 20-year or less, right? You can imagine they are very impatient with the network. They expect the stuff to be working as much as they expect to turn the tap on and water to flow out, right? If we cannot deliver a very reliable network, then we are not going to make the case for why this product should be deployed in the field. So that's an important piece that we have to do. But I do believe that with a larger and larger participation of people and building up this ecosystem, we will actually be able to do better than any closed source ecosystem, which is exactly what we have seen in the operating system space. If you look at what Linux has been able to do, to detect and debug and handle issues. But I do believe that that's important for us. Okay, so again, so just to summarize, I just want to say that we are really at the cusp of this revolution that is long. Okay, so we do need open SRAN, we do need open source, the core, the edge, and so on. But we also need openness in the hardware designs, right? Openness in the processor and computing systems, some of which are already happening. We do need SDRs that are open enough for us to play with and try out new things that are production ready and for commercial systems too. So, and we need to enable this ecosystem all integrated and perform reliably at all times. Okay, so that's our challenge. And at NSF, we stand ready to help. So it's our job working with our partners in the DoD and NIST and others to help you guys get there. Because we believe that openness is advance faster and compete better. Okay, so with that, let me stop and take some questions. Yes. Oh, yeah.
Thanks. So, Thyaga, can you comment on private 5G deployments with ORAN right now? Are there like a lot of them, or it's very limited?
Yeah, it is very limited. Yeah.
Talked to Ratuken, they were, and even Reliance, I was like, you guys should use it and whatnot, right? But it's like really hard.
But they're the best kept secret, I think, right? I think every, so Dinesh, you were not there when I talked a little bit about what my earlier experience was with Lucent, right? So there are companies that are trying these things out, but they're afraid to show the results to the open world because they're afraid that it will essentially cannibalize their existing businesses. If people start demanding a cheaper solution because it works well, they're afraid of the impact it will have on their core businesses. They all invested billions of dollars into building these things out. And there's a huge worry about that thing being cannibalized entirely by this next generation stuff. And I mean, Rakuten is a great example, right? They have done this stuff. They have results. Again, the only challenge with Rakuten was they started so early that the system was not robust enough at that point, right? Now, initial results were used by others to beat the open source community down. But there are deployments today that are out there. I hear people speak about it. I cannot say it publicly because they don't want us to reveal it. But there are, when we talk with vendors, we hear that it's there. All right. The question is, there needs to be this critical groundswell somewhere. Somebody has to put this out there and publish it. But again, I'm not saying that the challenges don't exist. Deployments are there, right? So the question is, customers need to demand them. So there's a great marketing campaign happening by the carriers that essentially say, oh, if you're a customer, an enterprise customer, you don't trust me, you don't want private 5G, or you want our solution. All this open source stuff doesn't work. There's to kind of go against that onslaught of marketing and kind of somebody. No. This is a very workable solution. It's a little bit challenging because power dynamics here, right? Big carriers versus small entrants. Why would you trust a small entrant over the big carrier thing, right? The community is not that ready yet to adopt the disruptors like how you used to do with the Silicon Valley folks back in the 90s, like or even the late 2000s.
So second question, are there like some credits or like which FCC used to offer previously for Open RAN? Right now, everybody's trying to classify, even Nokia's and Ericsson deploying custom solution are trying to qualify for those credits, right? So
yeah, so I think that's a very interesting model. So I've not heard of that. But one of the things, this is one of the challenges that I'm going to lay out to you all, right? You're all passionate about this space. If you have interesting ideas to accelerate deployment, I told you, right? So this is the big challenge. Our real opportunity is to get us to that deployment challenge. If you have some creative solutions on how we can do that, please let us know. So SJ is here. I'm happy to talk to people as well. Feel free to reach out to us offline. We really want to know what are the creative ways you think you can do. We can do this, and we will go talk with our agency colleagues and try to figure out ways to make it happen.
Any other questions?
Thanks. So Mark Ruffini, Trinity College. So I've seen that the NTIA has a $1.5 billion budget for an Open RAN.
Yes.
I mean, this seems like a great opportunity to really build this to a next level stage. Even, there's not much hardware today available for this.
Yeah.
This could be the opportunity to get something really solid.
Absolutely. I think it is a great opportunity. I think we are really lucky that Congress deemed it deemed it important enough to give that money out there to the NTIA to spend on this particular thing. As you probably are seeing in some of the releases trickling out, so they are planning to do that funding through that initiative in multiple tranches. I think they announced the first tranche last like three months ago. So mostly focused on R&D projects, but then there's a test and evaluation piece that's going to come out soon on Open RAN. And then the idea is to create further investments, make further investments into strengthening the system, making it more robust. So we are working with them on the design of that. So again, this is where it's important for us to get your feedback. What are the ways in which we can make that better? We would love to take that input and share with the NTIA folks as well.
Hi, I'm Yongdae Kim from KAIST. I work on security, and we've been finding many vulnerabilities in the implementations, commercial implementations in baseband and core networks, as well as sometimes 3GPP and GSMA refuse to patch some of the vulnerabilities, and those vulnerabilities exist. So what do you think about the future of Open RAN, considering the current security standard, or security practices of these vendors and the standard bodies?
Yeah, so you're touching on a very sensitive subject, right? So many vendors rather not have us talk about the security issues. So I remember back in 2016, or actually maybe it was 15, we funded a research project by Professor Chun-Yi Peng, who was at Ohio State at that point, who's now later on moved on to Purdue, on trying to expose vulnerabilities in cellular networks, right? And as you know, NSF runs a merit review process. The prevailing feedback, the feedback that we got from most folks is, why is this even a research problem? Cellular networks are very secure. That was the assumption, that largely because I call this black box fallacy, right? Just because you can't see inside, you assume that things are good. But we went ahead and took the risk and funded it anyway. And you wouldn't believe, within the first year of her project, she discovered almost 15 different vulnerabilities, massive vulnerabilities, that of course, she did the right thing and disclosed it to the vendors first and had them fix it, the operators and vendors fix it. But that report that we got from that project was so shocking. And I didn't expect that personally. I funded the project. I was like so shocked by the number of vulnerabilities that were there, the nature of the vulnerabilities. Some of them were easy, right? You could sit down with one device and you could generate enough denial of service attacks to bring down cells like, at scale, right? So I do think they exist. Now, we don't want to have a 9/11 moment to find that out. And this is why I think it's important for us to stress why open source is much better than these things. Now, I wish somebody would invest in a black box analysis of these networks and publish it. Now, of course, a lot of the vulnerabilities that she discovered, for example, many of them are not published publicly, but they were definitely fixed. We don't have that mindset here, because of the national security risks at play. Okay, but I do think this is a real problem. Closed source development, it's the same developer, right? If you're an open source developer sitting here, you may go to a vendor and you'll be doing the same thing there. Your code practice is not any better today just because you happen to work at a different place. They are not very good software development shops. They are used to working on proprietary hardware. I can tell you this, most telecom carriers and vendors who supply equipment to them are not proper software development shops. If Microsoft, which does this for a living, still has not been able to actually 100% bug code, what confidence do we have that those vulnerabilities exist today? They are easily identifiable. All it takes is a dedicated attacker. So this is why I think it's more important for us to trust open source here and leverage that openness, that we can share what exactly are our vulnerabilities and how we are fixing.
And I'll take advantage of having the mic and say, one of the things we're very interested in doing at srsRAN is starting a srsRAN security hall of fame, similar to the GSMA hall of fame, where security researchers can do responsible disclosures of vulnerabilities in the open source code and have a very clear process for fixing those issues and then publishing the findings. Yeah, so that is something that's on our roadmap very much. Any other questions?
You'll get your question, don't worry.
Hi, I'm Rani Haibi from the Linux Foundation. First, I wanted to thank you for evangelizing open source collaboration. You're pretty much doing our job, so thank you. One thing we witnessed is that when it comes to students and researchers, they're sometimes kind of blocked from contributing to open source projects because their institution is concerned about monetizing the IP and have some categoric blocks to contributions. So my question is, and I'm sensing you're familiar with that, have you seen models that work well, or what is your tips for people in the room on how to be able to contribute while still complying with the organization policies?
Yeah, so I probably am not aware of many organizations that right? So how many academics here have contributed to open source projects? Show of hands. How many of you have had the situation that we just heard, like your institution discourages you from doing it? So yeah, so I think it's like a minority of institutions that do so. But again, we want everyone to be able to do that. So I would love to understand more about what the institution challenges are on those aspects. I think within the US, at least, there's a reasonably open culture there. I cannot speak to that for other international countries as well, but I do want to have the faculty members ask the question, if they want to contribute, and yet they are blocked by the institutions, to ask the question, why is it that we have to think of this commercially? Often I feel like faculty don't have the training enough to ask those questions. And because the moment legal counsel comes and tells you, no, we cannot do this, They say, fine, I'm done. I don't have any time or resources to go deal with this stuff. If you don't want me to do it, I will not do it. But I think it doesn't require a lot of pushback, just a little bit of strategic questions. You just have to ask the right questions and keep pushing back if you're passionate about it. And if they still don't relent, come talk to us at NSF. We really want to know, right? So if you are somebody who's being stymied by such organizational policies, come tell us. We want to understand and we will help.
Thank you.
And I'll give the last question to Hongwei.
Thank you. So actually, this is a good segue to the question I was thinking about. You know, at the core of the open source are the people, right? I think oftentimes I feel our students, including ourselves as professors, are not well trained. So I'm curious whether NSF have put some thought about, besides like programs and like polls, are there any existing even or emerging formal mechanisms by which we can really bring open source training education into classrooms?
So we don't have any right now. That doesn't mean we are not thinking about it, right? So this is one of the opportunities that I feel that we have in this new directorate that we have created. Again, as you all know, the directorate was created from the CHIPS and Science Act investments. And we have this broad mandate to support acceleration of translation of research across all areas of science and technology. And part of that is we don't even understand what are the new mechanisms that need to exist to make it just one effort that we started. So again, if you have interesting ideas around this, we want to know. And again, I cannot promise you that everything will become a program within the next year or two, but as we start collecting the ideas and start seeing themes and trends emerging, we will keep pushing that envelope, because translation takes multiple different pathways. And we feel that open source is here to stay and it's a component. And whatever it is that we need to do, whether it's open source in wireless, in molecule design and whatnot. So we really are looking at it at a broad range of areas. And we would love to take your inputs and design programs to make them most effective.
Super. Thank you very much, Thyaga. Please thank our speaker.